It seems like we live in a totally interconnected world. Wi-Fi access everywhere we go. We can search for anything, watch a YouTube video on anything. However, for someone like Sam living in a remote part of Brazil, he doesn't have access to any of these things. In fact, only 40% of the world's population has access to internet. Most of these people live in cities, but even people in rural areas with internet access may have only one option to choose from at a very high price and low speed. So what is the solution? A HAP.
What is a HAP? A high-altitude platform. They usually come in the shape of balloons, airships, or solar planes and are located in the Earth's stratosphere. Let's make our way up there. On the ground level is where current internet ground infrastructure is located. Birds, who do not deliver internet access, fly at around 5,000 feet. Planes fly at about 30,000 feet. At 60,000 feet, we reach the stratosphere, and this is where HAPs fly once they have government permission. There is little to no wind up here, although HAPs do still face the challenge of staying in one place. If we keep going, we'll reach satellite height. Satellites also currently deliver internet access.
HAPs are still at the innovator stage, with Facebook, SpaceX, and Google currently running experiments such as Project Loon. HAPs are likely to gain adoption in providing rural areas and developed countries with high-speed wireless communication. They will go beyond that niche by providing wireless communication services to third-world countries and gaining access to bandwidths across international borders.
Besides smaller energy consumption, HAPs are deployed faster, especially in areas with little or no infrastructure. HAPs use the same radio frequencies as other internet companies and phone companies, and are more complex because they need to land frequently to be maintained and fueled. HAPs are costly and difficult to make, so they can't be tried easily. The news about Google's Project Loon can be seen anywhere in the news.
The main parts needed for a HAP are systems on the ground that can receive signal, broadcasting equipment for proper frequencies, internet or other service providers, and systems of HAPs to cover an area of integration with other systems. Current internet providers and cell phone companies might want to buy their own HAPs, and governments may adopt HAPs for surveillance.
To understand how HAPs fit into various industries, HAPs features are the speed of the internet. The product is the wireless internet itself. The platform are the high-altitude balloons or airships, which can deliver internet or other services. The businesses involved are internet service providers like Comcast, companies launching balloons like Google and Facebook, and the actual manufacturers of balloons.
Meet our friend Porter, the younger version of him, to look at his 5 forces. There's a low threat of new entrants due to high barriers to entry and high initial capital needed. Threat of substitutes is medium because the availability of substitutes depends on how developed a country is. Suppliers have a high power because the market is concentrated with undifferentiated products, and the bargaining power of buyers is low in areas without internet. The rivalry is high in existing markets and low in emerging markets. HAPs companies must apply a focused strategy on providing internet to rural areas, which is where the above-average profits will reside.
Since patents protect HAPs platform control, deployment, and balloon systems, the patent owners seem to have an edge on the competition. If we could patent something around this technology, it would be a fueling system to keep HAPs in the stratosphere for the longest without being expensive or harmful to the environment. NASA is launching a competition to see who can create the best fuel system for a HAP, which will encourage open innovation in at least one area of HAPs.
So what does our friend Christensen have to say? He's not this old, but anyway. The next best alternatives to HAPs are tall base stations and low Earth orbit satellites. HAPs will disrupt ISPs by going after customers in areas difficult to reach. The big guys are well positioned to fight back with lower prices and better infrastructure. The inertia lies in the easy and wide adoption of current ISPs, but Google, Facebook, and SpaceX could break it. They're also poised to win the delivery of this technology at the moment, with Comcast and other internet service providers being fast followers. Governments could be fast followers. Well, at least followers.
For HAPs to develop, we need experts in network security, computer science, sustainability, and climate change. HAPs pose the ethical issues of privacy, monopoly, and charging high prices. The opportunity of internet available to everyone relies on the government making it a public good.
1 year from now, Google Loon will have successfully reached its goal of launching one ring of balloons throughout the world. 5 years from now, either Google, Facebook, or SpaceX will emerge as the leader in the HAP industry. 15 years from now, HAPs will be crossing the chasm and gaining an early majority of users. Where would we invest in all of this? Coming up with a reliable, economically feasible, and environmentally sustainable way to fuel HAPs. HAPs will pave the future for people like Sam to have affordable access to the internet and connect our world.
Expert Dr. David Grace, a scientist from University of York, said, "The potential of the system is huge, with possible applications ranging from communications for disaster management and homeland security to environmental monitoring." Keep on the lookout for news about HAPs. This has been Jessie and Una taking you on a technology trek from Willamette University.